Okay, so what we're looking at today is multiple angles and product of angles. So talking about 2 times an angle or 4 times an angle, and then product is sum and sum to product. Now, multiple angles formula. So in this section, you've studied the first category, KU, where we can have multiple angles and squares. Now, sine of 2u is equal to 2 sine of u times cosine of u. Cosine of 2u is cosine squared of u minus sine squared of u, or 2 cosine squared of u minus 1, or 1 minus 2 sine squared of u. It could be any of these three. And tangent of 2u is just really this one here. Now, for both of these here, sine of 2u, well, I can say that's the same as sine of u plus sine of u. 2u, u plus u would give us 2u. Now, if we look at, or if we remember our formulas from yesterday, sine of u plus sine of u are angles. This should be, well, it'd be sine of u cosine of u plus, well, sine of u cosine of u. Because yesterday we talked about u and v. Wait a minute, these are the exact same thing, aren't they? So this is really the same as 2 sine of u cosine of u. Well, that is our formula, isn't it? 2 or sine of 2u, u plus u is the same thing here. It's really, we use that sum formula to get this multiple angle formula. Same thing's true with cosine. Cosine of u plus u, well, that'd be cosine of u times cosine of u minus sine of u times sine of u. Well, it's just times itself, because cosine times cosine will give us cosine squared. Sine times sine will give us sine squared. So we have this here. Now, you're probably wondering, where in the heck did they get these other two, right? According to our trig properties, sine squared is the same as 1 minus cosine squared. Because it goes back to our sine squared of theta plus cosine squared of theta is equal to 1. Well, sine squared of theta is equal to 1 minus, and cosine squared of theta is equal to 1 minus So if I replace sine squared with 1 minus cosine, I'd have cosine squared of u minus 1 minus cosine squared of u. Well, negative and negative makes a. So I have 2 cosine squared of u minus 1. Well, I can replace cosine squared of u with 1 minus sine squared. I just get 1 minus 2. And that's it. So again, this is just really manipulating these formulas. Does that make sense? Kind of this, we're getting this here, kind of how these formulas work. Now, again, always the big question is, why does these matter? Well, now if I know, say, twice an angle, because for the most part, I mean 60, 30, 60, 90, 30, 45, 90, if we were restricted to just those there, then this would be a little bit more helpful. But actually, there's some cases like sine of trying to find something like this here, this would be actually half angles. It works better that way. But for these here, most of these don't make a whole lot of difference. Because if it was like sine of 120, well, I can just use a unit circle to find it. But if we didn't have 120 on the unit circle, we didn't have it at our availability, but we had 60. Well, this is the same as 2 times sine of 60 times cosine of 60 would give me sine of 120. And that's why these are helpful. Because if I didn't have the massive amount of availability of this calculator that y'all have, I mean, that little $15 calculator can do all this. If we didn't have it and we're restricted on our information, these here are really helpful in finding a lot of other angles that we couldn't get otherwise. Because now with these formulas here, for the most part, 30, 45, and 60 can give me a lot of stuff. Because here, well, 30 can give me 60, well, 60 can give me 120. 45 can give me 90. And I can use any of these multiples to figure this out. Solving a multiple angle formula equation. So we have 2 cosine of x plus sine of 2x equals 0. Well, doing sine of 2x is a little challenging because I prefer not to use 2x inside of there where I have x also. Because this here is x, this here is 2x. If I can avoid having that, I'm going to try to. And what I do know is that sine of 2x is the same as what? 2 sine of x cosine of x. Because sine of 2x is equal to 2 sine of x times cosine of x. We can replace those out. Well, now we can start solving. Well, hey, that's in common in both, yes? So I can factor it out. So I can say 2 cosine of x times 1 plus sine of x is equal to 0. 2 things multiplied together equal 0 means one of them has to be cosine of x is equal to 0. Well, for here, cosine is equal to 0 at not 0, but 4, going straight down, because where x is 0 is right on the y-axis, up and down, straight up and down. Now, on the other one, we would subtract 1. Which would give us sine of x is equal to, well, here, let's see here. I feel like I got these backwards. This should be 3 pi over 2. Yes? I always flip those. It's so easy to flip those. 3 pi over 2. So we get this here. Yes? No one's mind's been blown yet? Any questions on this here? We good with this here? Yes? Because we changed it to our 2 sine times cosine. We're able to factor out the 2 cosine, and we solved. Factored and solved. Now, if we were dealing with, so again, it didn't give us an interval, we really need plus 2 pi n, 2 pi n. Two pi n. So if I'm listing all of the answers, do I really list repeated answers? So the 3 pi over 2 and 3 pi over 2, I only really need to list it once, yes? What happens if I add pi to pi over 2? What do I get? I get 3 pi over 2, don't I? Because we're adding 1 to it. So 1/2 plus 1 is 3/2. So wait a minute. If I can do that, couldn't I just say that this here is pi over 2 plus what? Not 2 pi. Because pi over 2, if I add pi to it, I get 3 pi over 2. And if I add pi over 2 to that, I get back to our another term. I get a value that would be this here. And these here really just switch units of pi. Y'all see that there? Because pi over 2, if I add pi, I get 3 pi over 2. If I add pi over 2, well, I get pi over 2 plus 2 pi for this here. If I add it again, so these here, because they're a pi apart, I could simplify it to just pi over 2 plus pi in. And this is the same as these two here. I will take either version. I will take this as an answer. Because it's not always easy to see that pi over 2 plus pi in is the same thing as pi over 2 plus 2 pi in and 3 pi over 2 plus 2 pi in. See that those are the exact same. Pi over 2 and 3 pi over 2. Now, I'm going to come back up to the top. I want to check it. 2 cosine of pi over 2 plus sine of 2 times pi over 2 is equal to 0. Well, cosine of pi over 2 is going to be what? Well, cosine, so pi over 2, we can look at the chart, and it's straight up, and that would be 0. So we'd have 2 times 0. Yes. So this whole thing is just 0. Now, 2 times pi over 2 would be the same as sine of pi. What is sine of pi? Zero, isn't it? So pi over 2, we're good, yes? Works out just fine. 3 pi over 2. 2 cosine of 3 pi over 2 plus sine of 2 times 3 pi over 2 equals 0. Well, cosine of 3 pi over 2 is just 0. Here, it's going to be sine of 3 pi. Well, 3 pi is 0. It works. Because 2 pi would give us back at 0. Pi would give us back over here, and it is 0. So these work. So some of these, especially when we have sine and cosine, it's going to be good to check it just to make sure the signs all match up and everything works out. Questions on this here? We good? For the most part? Let's see here. So we have 8 through 26 to start off with, yes? 8 through 26 even. Pick one of those that you think would be...
26 even?
So 8 through 14 even.
8 through 14?
Ooh, 14. Looks... Because we have tangent of 2x minus okay. Now again, I think this is going to be the one to do because tangent is a little tricky. Not too much. But we know that tangent of 2x, because we have that formula for our double angle, is going to be a fraction. Because it's our tangent, 2 tangent over 1 minus tangent squared. 2 tangent of x over 1 minus we have this here. And again, we're wanting to try to solve this for x. I don't know about y'all, but I don't like having fractions if I can avoid it. I'm going to multiply everything by 1 minus tangent squared of x. Now this is different than dividing it out because it's not eliminating something, it's just moving everything so it's on the same thing, same level. Because these would cancel, giving us 2 tangent of x minus, because negative 2 times 1 gives us negative 2 cosine of x. Negative 2 cosine of x times negative tangent squared would be plus 2 cosine of x tangent squared of x equals 0. It's still 0. Here, well, since this is cosine of x and tangent squared of x, it doesn't quite work out. Now we need to see where we want to go next. That shouldn't work. Because now I'm just looking to see what would be the next best strategy for getting x by itself. Okay. So this here was the right track of what we're doing. Now, what we're going to do with this here is actually convert it over. Because tangent, well, everything has a common factor of 2. I'm going to divide everything by 2. Now, luckily, doing this here isn't changing anything. It's just reducing that scale factor. Because each one of these was scaled by a factor of 2, so I can divide it, and it's not going to change our zeros. Now, this here would have taken me a little bit to get to. And not because it's not something I know that this does work. It's something I try to avoid because, at least for this problem, because if you notice we have some squared, some not squared. It's just a combination of these fractions and non-fractions. So it makes it a little bit more tricky. And I normally try to avoid this because if there's an easier method, I want to try to do it first before converting everything into this form here. Because this here, it's not that it's more difficult or harder, it's just harder to work with. It's a little bit odder to work with. I like that phrasing better, odder to work with. Come on. Now, one thing that we hopefully notice that we have cosine and cosine here. So sine over cosine here is not going to change. But this here, this is going to cancel out with one of these here, giving us sine squared of x over well, we do have two fractions again, yes? We're going to put them all together, or we can factor out 1 over cosine. Either way. But let's put these all over the same denominator, cosine of x. Well, two of them are already there. We just need the middle one over cosine of x. Well, that makes the numerator cosine squared of x. Now they're on the same denominator, yes? So that means we can add the numerator. So we'd have sine of x minus sine squared of x plus sine squared of x is equal to 0. Yay. We're one step closer. I wouldn't times it by cosine of x. I can factor it out. And again, it is tempting to want to do that multiplication of cosine of x on both sides. And the reason we don't is, well, on the right-hand side, cosine of x times 0 would be 0, yes? And on the left-hand side, it would simplify out completely. But what did I do? I just removed a cosine x completely from the equation. So what we're risking if we do that is the possibility of losing values of x that would make this function equal 0, because we just eliminated a variable out. We can't do that. With numbers, it's fine because it's not changing the solutions, it's just changing everything else. It's a scale. Eliminating scale factors is fine. Eliminating variables, not so much. So we can factor it out. Oh, this is so close. I mean, cosine squared and sine squared, it's so close to being 1 if only the cosine was positive and not negative. But over here, I can say 1 over cosine of x is equal to 0. This we can already split off. Here, I'm going to do 2 steps in one. One of them is going to be moving sine squared in front. What is cosine squared the same as? 1 minus sine squared. So this here is our trigonometric identity, or this Pythagorean identity. So 1 over cosine of x equals 0. Will this ever work? Because can I divide 1 by anything and get 0? No. Because the only way for a fraction to be equal to 0 is if the numerator is 0. The numerator is 1. There's no way for 1 to equal 0. So that's done. There's no solutions there. Now over here, well, the negative and negative make a, and we'd have negative 1. So really we have 2 sine squared of x plus sine of x minus 1 is equal to 0. Because the ones, this is factorable. So 2 sine of x and
So the first one's 1/2, negative 1/2, right?
mm-hmm. I want to say pi over 3 and, no, not pi over 3 because it's negative. It's going to be in the fourth quadrant. What is it? 5 pi over 3? No, you're good. 7 pi over 6 and 11 pi over 6. And I think you got the other one as sine equals 1. And sine equal to 1, sine of x equals 1, is only one spot. That's where x is equal to pi over 2. Straight up. Seven pi, 11 pi, and pi over 2. Yes. Okay.
I didn't really choose it. You kind of said, oh, hey, 14.
Even if we didn't choose it, we would have come back to it. So we can check it. And again, for most of these here, when you check it, you can plug these in. Just make sure the calculator's in radians when we do this. Now 2 times 7 pi over 6, so that would be tangent of 7 pi over 3 minus 2 cosine of just, well, 7 pi over 6. 7 pi over 3, that's the same as pi over 3, because 6 pi, or 6 over 3 is 2, so we're one more than that. So in the unit circle, it would be pi over 3 for 30 degrees, and tangent would be square root 3 over 3. Now, cosine of 7 pi over 6, we can look at 7 pi over 6, and it is negative 1/2. Yes. So negative 2 squared root of 3 over 2? Yeah, or 3 over 2, and if we multiply it by 2, it actually just works out to be. Well, it doesn't work, does it? Because here it's not going to give us 0. Mm-hmm. Over 3? Yeah. T squared root of 3. Yep. So this here does not work as an answer. Because it does give, it is a solution, it's just one of our ones that does not work. Make sure I did this right. Because it could be also that I looked at the wrong numbers. There we go. I wanted a positive one, yes?
Will they both be they're both...
They're flipped, because 2 times 1 would give us positive 2. I had it as negative sign. But really all that does is it changes it to positive 1/2 and negative 1. Five pi over 6 and pi over 6. And then this is 3 pi over 2. Mm-hmm. And these here should all work. Yep, I'm looking at this here. Also, values for which cosine is equal to 0 needs to be checked. Pi over 2 and 3 pi over 2. But we're good there. Mm-hmm. Or secant's equal to 0 is no solution. Yeah. Mm-hmm. And those will work. So these here are the solutions. So x is equal to pi over 6, pi over, well, they include pi over 2 and 3 pi over 2, and then 5 pi over 6. As it works out, pi over 2 actually does work. Because this here would be tangent of pi minus, well, cosine of pi over 2 is 0. And tangent of pi is 0 over 1, so this actually works out to be 0. But I don't think most of the other ones are going to be as tricky as that. We'll finish this up tomorrow, because this took more time than I thought it would. Especially with that one there, and we'll throw some more in.